Okay, here's two questions where you're asked to find a dissociation equation for them. So they have potassium permanganate. So here's potassium permanganate. Maybe let me just erase the stuff that I've got here already. So one of the questions, before you even break it into ions, is a question of whether it will break into ions. So if you put potassium permanganate in water, will it break apart? Some substances won't dissociate much at all. Some will dissociate completely, so it sort of depends. And the way you can tell whether something will dissociate or not is to look at this solubility table. Whoops. So this table right here, let me make it a little bit bigger. So if I want to know if potassium permanganate will will dissociate in water, what I take a look at are the two ions. So I have a potassium ion and a permanganate ion. And so when I look over here on the chart, I look at the top up here somewhere for either potassium or permanganate. The other thing you can look for is potassium is in this column right there. Let me move down a bit. Potassium there in group 1. And so if it's in group 1, then I can look at that column right there because I don't see permanganate anywhere here. So I look at group 1 and then I look down to see whether it falls here or here. So here potassium is a group 1, so I'm looking for permanganate. Since it's not here, it must be here. Therefore, and this one is the aqueous row. So anything along here is aqueous, and this one you would say it's a solid or would not dissociate. Okay, so this one will dissociate. So let me erase my little messing up that I did there. Oops. So it'll dissociate. I'll just get an eraser. Here we go. So if it'll dissociate, then I break it into its ions. Now, one question might be, well, this one, why do you break it into potassium ions and permanganate ions? Well, you look at the polyatomic ions, and things get broken into those substances. So if it's a polyatomic ion like permanganate, you just leave it at permanganate. You wouldn't write it as magnesium separated with oxygen. You would just keep them together like that. And permanganate's down here somewhere. Where's permanganate? There it is right there. There's permanganate right there. So anything that's in this polyatomic ion, you would keep it together. So this would dissociate in water, and I would write aqueous there and aqueous there. Let's try one. So here I have calcium hydroxide. Will it dissociate in water? Well, I can use my table. Here's my table, and I'm going to look up calcium. Calcium's in group 2. It's in this one. And so that's not shown up at the top. Oh, but hydroxide is. There's hydroxide. So if you're hooked up with hydroxide, if you're a group 1 ion, that's that column, or NH4, you're aqueous. Anything else will be a solid. So this one here, if I were writing a dissociation equation, I could say, well, you can put this in water, but it's probably going to stay as a solid. So it probably won't dissociate. Now, on a test, some people might write, and I'd be okay with this, some people might write and say, well, if you want me to write a dissociation equation, I can write one, calcium hydroxide as a solid. If you dump it in water, there's a possibility that it'll convert into calcium ions and hydroxide ions, both of these aqueous. There's a possibility that that will happen. Oh, I should balance it. Put a 2 there. So possibility that it'll happen, but it's not likely according to our chart. And so this introduces a concept you'll see in Chem 30 where they look at equilibrium. So some of this might dissolve into calcium and hydroxide, but some of the calcium and hydroxide might go the other way and form this stuff. And it turns out the equilibrium between these two is heavily favored to the calcium hydroxide solid. At any rate, on a test, if you wrote this down and say, hey, it won't dissociate in water, normally, I'd be fine with that. If you did write it and break it into its ions like this, I'd be okay with that too.